Now how to integrate this? All of you know derivative of tan is secant square. Integration of tan is secant square. But integration of secant is secant into tan. Cos 2x can be written as cos square x minus sin square x. Cos 2x can be written as 2 cos square x minus 1. A part of the function, if you take it as t, when you differentiate, you should get remaining part. In this 1 by cos square can be written as secant square. Again 1 by cos square can be written as secant square. Instead of b minus a, I am writing in the factors of denominator. X minus a minus x minus b. If you open the brackets, x cancels. Welcome to the session, dear students. So in my last class, I taught some of the problems of the exercise 7.3. Now we'll continue with more problems of exercise 7.3. So now exercise 7.3, find the integral of the functions. So now they give first one cos 2x minus cos 2 alpha divided by cos x minus cos alpha. So write it in the form integral cos 2x minus cos 2 alpha divided by cos x minus cos alpha with respect to x. So numerator is 2x, denominator is x. So you can write cos 2x in four forms. Cos 2x can be written as cos square x minus sin square x. Cos 2x can be written as 2 cos square x minus 1. Cos 2x can be written as 1 minus 2 sin square x. And same cos 2x can be written as 1 minus tan square by 1 plus tan square. Now because denominator is cos x, I'll write cos 2x as, can I write cos 2x as 2 cos square x minus 1. In between we have minus 2 cos 2 alpha can be written as 2 cos square alpha minus 1. Don't forget to put the brackets because here we have minus divided by cos x minus cos alpha with respect to what? Dx. Now simplify the numerator. In numerator we have 2 cos square x, integration of 2 cos square x minus 1. Open the brackets, it will become minus 2 cos square alpha, minus into minus becomes plus 1, divided by cos x minus cos alpha with respect to what? Dx. So now you can cancel plus 1 and minus 1, and further you can take 2 common. If I take 2 common, I will be left out with cos square x minus cos square alpha divided by cos x minus cos alpha. Here you can observe still we have not integrated, just we are simplifying. Numerator is in the form a square minus b square. All of you know a square minus b square can be written as a plus b into a minus b. I can write it as cos x plus cos alpha into, and 2 I'll take outside, cos x minus cos alpha divided by what? Dx. Sorry, divided by cos x minus cos alpha into dx. So observe the terms and cancel. Now I can cancel cos x minus cos alpha and cos x minus cos alpha. Now the given problem reduced. So now the given problem is simple. So into outside, integration of cos x minus cos alpha dx. Now integrate each term. To outside, integration of cos x dx minus integration of cos alpha dx, to integration of cos x, you know, sin x, minus integration of cos alpha is cos alpha into x plus c. My dear students, we are integrating with respect to dx. With respect to dx, cos alpha is treated as constant. All of you know what is integration of k dx. Integration of k dx is kx plus c. So integration of cos alpha dx is cos alpha x plus c. That's it. Here many people fail to understand this is constant. If cos alpha with respect to alpha means it will not be constant, it will be function. But inside cos we have alpha. Alpha is treated as constant. Cos of alpha is constant with respect to x. So integration of k dx is kx plus c. Integration of cos alpha dx is cos alpha x plus c. So this is a final answer. But here very important is we are using multiple angle. What is the multiple angle? You should be thorough with cos 2x or cos 2 theta. Cos 2 theta can be written as 2 cos square theta minus 1. So writing cos 2 theta in terms of cos square theta is important. So my dear students, here the major format is converting. So we had cos 2 alpha. Cos 2 alpha we wrote it as what? 2 cos square alpha minus 1. Cos 2 x and cos 2 alpha we wrote like this. Further, when you open the brackets, minus plus cancels, 2 will take common. Now we have in the form a square minus b square. So we have a square minus b square. You know, a square minus b square can be written as a plus b into a minus b. Here we have cos square alpha, cos square x minus cos square alpha, that we can write it as cos x plus cos alpha into cos x minus cos alpha, and these two terms are similar, they'll cancel. Remaining part integrating is easy. The next question, cos x minus sin x by 1 plus sin 2x. They want you to integrate. So integration of cos x minus sin x divided by 1 plus sin 2x dx. My dear students, if you differentiate the denominator, I will not get numerator. This is 2x, this is x. So what we should do? So denominator you can write it as 1 can be written as sin square x plus cos square x. Because cos square theta plus sin square theta is what? 1. Sin 2x. What is sin 2x? 2 sin x cos x. Plus I can write 2 times sin x into cos x. Numerator, let it be as it is. What is numerator? Cos x minus sin x with respect to dx. Now denominator you have to observe, it is in the form a square plus b square plus 2ab. What is a square plus b square plus 2ab? A plus b the whole square. So cos x minus sin x divided by a square plus b square plus 2ab can be written as a plus b the whole square. I can write it as sin x plus cos x the whole square. So sin x plus cos x the whole square gives you this with respect to dx. I'll use brackets for this. Now observe, a part of the function, if you take it as t, when you differentiate you should get remaining part. So whatever is present inside the bracket, sin x plus cos x, if I take it as t, what is derivative of sin? Cos. What is derivative of cos? Minus sin. So therefore do method of substitution. Put t is equal to what? The bracketed term in denominator. What is there in the brackets of denominator? Sin x plus cos x. Sin x plus cos x, take it as t. Differentiate, you will get numerator. So dt by dx. Derivative of t. Derivative of sin x is cos x and derivative of cos x is minus sin x. This is your numerator. What is dt now? dt is cos x minus sin x into dx. So now you can write the given problem as integration of cos x minus sin x, cos x minus sin x with respect dx divided by sin x plus cos x dx. So cos x the whole square. This is a question. So now observe this. Numerator I can write it as dt. Substituting. Denominator sin x plus cos x we took it as t and square. I am undergoing substitution. So you can observe the substitutions. What are the substitution? Sin x plus cos x I took it as t and dt is this. So in spite of sin x plus cos x in denominator, take it as t, power 2 is there, power 2 and this. So now further to integrate, rearrange in exponent format. So can I write this problem as integration of minus is missing, you know, integration of minus 1 by x square is what? 1 by x. Or can I write it as t power minus 2 dt? What is integration of t power minus 2? T power minus 2 plus 1 divided by minus 2 plus 1 plus c. Finally, answer is t power minus 1 by minus 1 plus c. That is minus, I'll take it out, and 1 by t plus c. So that is minus 1 by, what is t we took? Minus 1 by sin x plus cos x. Substitute the value of c plus c. This is the final answer. Minus 1 by sin x plus cos x plus c, or 1 minus 1 by cos x plus sin x plus c. Tan cube 2x into secant 2x. Good question. Integration of tan cube 2x into secant 2x dx. See, here we have secant x. Integration of tan is secant square, but integration of secant is secant into tan. So what I'll do is simple. Can I write it as integration of tan cube? I'll write it as tan square 2x into one more tan 2x into secant x dx. Can we write like this? Secant 2x, sorry. secant 2x dx. I wrote secant 2x dx as it is. A cube can be written as a square into a. So tan cube can be written as tan square into tan. So now we have tan into secant. You know, derivative of secant is secant into tan. So what I'll do is the first tan square, you know, tan square x can be written as secant square x minus 1. So I am not integrating, I am simplifying. So 1 plus tan square theta is secant square theta, or tan square theta is secant square theta minus 1. So tan square 2x, I am writing it as secant square 2x minus 1 into these two terms. First I'll write secant 2x into tan 2x dx. Let it be. Now do method of substitution. If I take secant square 2x as t, after differentiating you will get secant x into tan x, or just take secant 2x as t. What is derivative of secant 2x? Secant 2x into tan 2x into 2. So now do substitution. Put t as secant 2x. Put t is equal to secant 2x. So differentiate. So dt by dx is derivative of secant 2x is secant 2x into tan 2x into derivative of 2x is 2, chain rule. And you need numerator, it's a remaining part. What is the remaining part? Secant into tan. So bring 2 to this side. So dt divided by 2, transfer dx to RHS. So it will become secant 2x into tan 2x into dx. Now do the substitutions. So now we'll do method of substitution. So what I'll do, in the place of secant 2x, I'll take t. Wherever secant 2x is there, I'll put t. And secant 2x into tan 2x, I'll put it as dt by 2. Now the given problem reduces. So now we'll go to the given problem. So the given problem is integration of secant square 2x minus 1 into secant 2x into tan 2x into dx. Can I write this as integration of t square minus 1 into dt by 2? You know, 1 by 2 is constant, take it out. So if I take out 1 by 2 common, then I'm left out with integration of t square minus 1 dt. You know, integration of t square. Integration of t square is t cube by 3. Integration of minus 1 is minus t, outside plus c. Further simplify, it will become t cube divided by 3 to the 6 minus t divided by 2. Take 2 inside plus c. Substitute the value of t. What is the value of t? Secant 2. So answer is secant cube 2x divided by 6 minus secant 2x divided by 2 plus c. This is the final answer. So in the place of t, put secant 2x or substitute, you will get the required value. Next, tan power 4x. One of the good questions. Integration of tan power 4x dx. All of you know integration of tan is secant square x. So what we do is we'll convert it. Can I write it as tan square x into tan square x dx? So you know a power 4 can be written as a square into a square. And first term tan square x, I'll write it as secant square x minus 1. And the second term I'll retain as it is, tan square x dx. Now I'll take this inside and we'll simplify. So if I take it inside, all of you know 1 plus tan square theta is secant square theta. Instead of tan square, I'll write secant square minus 1. But the second term I'm retaining as it is. Now I'll multiply. If I multiply, I'll get integration of secant square into tan square. Secant square x into tan square x dx minus tan square into 1 is tan square x into dx. So now two terms are there. I'll integrate each. Now how to integrate this? All of you know derivative of tan is secant square. So further I'll write it as, first I'll write tan square x and then I'll write secant square x dx minus, you know, tan square x can be written as secant square x minus 1. This is integrable. So tan square x, I'll write it as secant square x minus 1 and I'll integrate. Now here in the first term, in this term, put t is equal to tan x. If I put t is equal to tan x, what is dt by dx? Dt by dx is secant square x and you need secant square x dx. So secant square x dx becomes dt. So now this is the substitution. In the place of tan x take t, in the place of secant square x dx put dt. So the problem reduces. I can write the given problem as integration of tan square x into secant square x. So tan square I write it as t square because I am taking tan x as t, and secant square x dx becomes dt, and second term as it is, I am not substituting anything, minus secant square x dx, and open the brackets, minus into minus plus 1 dx. Now simplify, it is t cube by 3, and integration of secant square x is tan x, integration of 1 is x plus c. Now substitute the value of t. What is the value of t? You assume tan x. So final answer is tan cube x by 3 minus tan x plus c. That's it. Here the key is what? Power 4 we write square and square. Tan power 4x, write it as tan square into tan square. First tan square, write it as secant square minus 1. Take tan square inside. Only for the first term do substitution. Next term is integrable. Now sin cube x plus cos cube x divided by sin square x into cos square x. Split this and integrate. Integration of sin cube x plus cos cube x divided by sin square x cos square x dx is the question. Can we split this? Can I write it as integration of sin cube x divided by sin square x cos square x plus cos cube x divided by sin square x into cos square x. So now integrate this. I can cancel sin square and 1 sin, and cos square and cos cube. Cos cube by cos square becomes cos. Now integrate this. So we are left out with integration of sin x by cos square x. You know how to integrate sin x by cos square x plus cos x by sin square x. Now both are integrable. We'll integrate them. So now I can write it as integration of sin x divided by cos x into 1 by cos x plus cos x divided by sin x into 1 by sin x. Now both I can integrate individually. That is integration of, all of you know, sin by cos is tan x into integration of 1 by cos x is secant x plus cos by sin is cot x into 1 by sin is cosecant x dx. So now both are integrable. All of you know, integration of tan into secant is secant x, integration of cot into cosecant is minus cosecant x plus c. Simple and direct. Next we have cos 2x plus 2 sin square x by cos square x. Again, cos 2x can be written in terms of sin square x. I can write cos 2x can be written as 2 cos square x, 1 minus 2 sin square x, 1 minus 2 sin square x plus 2 sin square x cancels, and I'll be having the remaining part. So integration of cos 2x plus 2 sin square x divided by cos square x. It is pretty direct if you observe. All of you know cos 2x can be written in terms of sin 2x. So cos 2x is 2 cos square x minus 1, or I can write 1 minus 2 sin square x. Instead of cos 2x I can write what? 1 minus 2 sin square x. So numerator, instead of cos 2x I write 1 minus 2 sin square x plus I am left out with 2 sin square x divided by cos square x. Numerator you can simplify directly. So now, minus sin square x and plus sin square x cancels, and we are left out with 1 by cos square x. It is easy. Integration of 1 by cos square x, all of you know 1 by cos square can be written as secant square x. So integration of secant square x dx, all of you know integration of secant square x is what? Tan x plus c. It's pretty direct question. You should be thorough with multiple angles to solve. Next, 1 by sin x into cos cube x. Little tricky question. Here thinking is very much required, and these are all POPs, practice oriented problems. There you can't sit and trial. See here, cos power odd number, sin power odd number. So cos power is more. Try to make it secant square. What I'll do is simple. I'll write it as 1 by sin x into cos cube x is there. I'll divide and multiply by 1 more cos x. Cos x by cos x. So can I write like this? Cos x by cos x. If I cancel, it will be same. So now further I can write the given problem as integration of 1 by this sin by cos. I'll write it as tan x and this cos power 4x. Further cos power 4x I will simplify. Can I write this as 1 by tan x into, can I write it as cos square x into cos square x dx. So 1 by cos square, you know, secant square. So I'll take secant square x in numerator divided by, I am left out with tan x into, again I have secant square x dx. So 1 by cos square is secant square, again 1 by cos square is secant square. One of the secant square I will write it as 1, all of you know 1 plus tan square theta is secant square theta. So 1 plus tan square is what? Secant square. Instead of secant square, can I write 1 plus tan square? I'll write it as 1 plus tan square x divided by, I have tan x, and second term I'll retain it. Second term is secant square x. Now the purpose is solved. Simple, put denominator TST, put T as tan x, differentiate, you'll get it. So converting this, dividing, multiplying cos x is intellect, and cos power 4x, it will become cos power 4x can be written as cos square into cos square. In this 1 by cos square can be written as secant square, again 1 by cos square can be written as secant square. One secant square you write it as 1 plus tan square, other secant square retain it. Now do the substitution. Substitution is simple. Put t is equal to tan x and differentiate. If you differentiate, dt by dx gives you secant square x, and we need secant square x. So dt is what? Dt is exactly secant square x into dx. So now the given problem can be written as integration of numerator 1 plus t square into dt divided by t. Split this. So it will become integration of 1 by t plus t square by t square by t dt. So now integration of t square and t cancels, integration of 1 by t dt plus integration of t dt. What is integration of 1 by t? Log t. Integration of t square by 2 plus c. And what is t? T is log tan t. So log tan t plus tan square t. Sorry, log tan x by tan square x by 2 plus c. This is the answer. So the place of taking t as tan x is the hint. Next we have cos 2x by cos x plus sin x the whole square. Very simple. Cos 2x can also be written as, so numerator we have cos 2x divided by, we have cos x plus sin x. After seeing cos x plus sin x the whole square, so cos 2x can also be written as, you can write cos 2x as what? Cos square x minus sin square x. So my dear students, depending on the situation, depending on what is given, you can write cos 2x formula. So you should be thorough with the cos 2x multiple angles. Cos 2x can be written as 2 cos square x minus 1, cos 2x can be written as 1 minus 2 sin square x, cos 2x can be written as cos square minus sin x, sin square x, cos 2x can also be written as 1 minus tan square by 1 plus tan square. Because I saw cos x plus sin x, I am writing cos 2x as cos square x minus sin square x. Again, numerator is in the form a square minus b square. All of you know a square minus b square can be written as a plus b into a minus b. So numerator I can write it as cos x plus sin x into cos x minus sin x dx divided by, denominator is cos x plus sin x. Now I can cancel whole square. So now I can cancel one term. So 1 cos x plus sin x and power 2 cancels. They're like terms. So now remaining part, write it. What is remaining? Integration of cos x minus sin x. I'll write it cos x plus sin x, or can I write sin x plus cos x, one and the same? A plus b or b plus a. Why? Because if I take t as denominator, what is denominator? T is equal to sin x plus cos x. Differentiate, you will get numerator. So now do dt by dx. Derivative of this gives you derivative of sin x is cos x, derivative of cos x is minus sin x, and we got cos x minus sin x. Further, dt becomes exactly cos x minus sin x dx. So now do the substitution and get the answer. So now the given problem I can write it as dt divided by t. All of you know integration of dt by t is log t plus c, that is log of what is t? T is what? Denominator, that is cos x plus sin x or sin x plus cos x. Sin x plus cos x or cos x plus sin x plus c. So I hope all of you got this. Next, sin inverse of cos x. So outside we have sin inverse, but inside we have cos x. Sin inverse of cos x dx they want you to do. So integration of sin inverse. So outside I have inverse trigonometric sign. So you know cos theta can be written as In mathematics, cos theta can be written as sine of 90 minus theta. Do you agree or not? Instead of cos theta, can I write sine of 90 minus theta? Now sine inverse cancels, so we are left out with integration of pi by 2 minus theta with respect pi by 2 minus x, sorry, cos x it is. So because it is cos x, I should write it as, so cos x in maths can be written as sine of 90 minus x. So sine inverse cancels, we will be left out with 90 minus x dx. Now integrate each term. So integration of pi by 2 dx minus integration of x dx. Integration of pi by 2x is pi by 2 times x. Integration of x is x square by 2 plus c. Integration of constant into x, k dx is kx. Integration of x per n is x per n plus 1 by n plus 1 plus c. Simple and direct. But here you should know allied angle. What is that? Cos theta in maths can be written as sine of 90 minus theta and vice versa. Sin theta can be written as cos of 90 minus theta. Next, 1 by cos of x minus a into cos of x minus b. Observe this. Simplifying this is difficult. So we have to use all the tools of algebra and compound angles. 1 by cos of x minus a into cos of x minus b. So what I'll do, I'll introduce sine compound angle so that the problem reduces. What I'll do, sine of reverse I'll introduce. Sine of b minus a, divide and multiply by sine of b minus a. All of you know b minus a is what? Constant. So b minus a is constant. So introduce sine of b minus a, 1 by sine of b minus a. I'm dividing and multiplying sine of b minus a. If I cancel this, it will be same. B and a are constant. Sine of constant is constant. So I can divide and multiply this. Denominator, let it be as it is. Cos of x minus a into cos of x minus b. Till the end, will not disturb the denominator. We'll arrange numerator in the form of denominator. They gave 1. Can I write 1 as sine of b minus a by sine of b minus a? Now, I'll write b minus a in the factors form. What are the factors we have? The factors we have is integration of 1 by, sorry, outside we have same thing, 1 by sine of b minus a. This continues. So I'm left out with, so that is 1 by sine of b minus a. This will be as it is. And here integration of sine of b minus a, I'll write it as sine of x minus a minus x minus b. Can I write like this? So x minus b. So if you open the brackets, you will get same. Cos of, we have x minus a into x minus b. Very interesting. See here, I wrote x minus a minus x minus b. If you expand this, what you will get? X minus a minus x plus b. Do you agree? So minus x plus x cancels, minus a, it will be b minus a. So instead of b minus a, I am writing like this. We had b minus a. Instead of b minus a, I am writing in the factors of denominator. X minus a minus x minus b. If you open the brackets, x cancels. Minus of minus b becomes plus b. It will become b minus a again. So b minus a badlige. And x minus a minus x minus b bardini. Now we'll split this. Now let me split this. So 1 by sine of b minus a will be as it is. What I'll do is, all of you know sine of a minus b. What is sine of a minus b? Sine a cos b minus cos a sin b. So this will become sine of x minus a into cos of x minus b minus cos of x minus a into sine of x minus b. I am using compound angle. What is compound angle formula? Sine of a minus b. What is sine of a minus b? Sine a cos b minus cos a sin b. So now denominator will be as it is. Now split them. So 1 divided by sine of b minus a. Now splitting this, you get sine of x minus a into cos of x minus b divided by cos of x minus a into cos of x minus b. In between I have minus cos of x minus a into sine of x minus b divided by cos of x minus a into cos of x minus b dx. Now integrate this with respect to dx. Now cancel the terms. So here I can cancel cos of x minus b, cos of x minus b. Here I can cancel cos of x minus a, cos of x minus a. Remaining terms or retained terms, to write it. So now I am left out with 1 divided by sine of b minus a into integral of sine by cos. You know, sine by cos is what? Tan of x minus a minus, again sine by cos, tan of x minus b. Now both are integrable. Integrate them. So outside we'll have 1 by sine of b minus a, and integration of tan. What is integration of tan? Log of secant x. So this will become log of secant of x minus a minus this will become log of secant of x minus b. You can leave it here. Or further simplification. Further simplification, all of log a minus log b can be written as log a by b. I can write the final answer as 1 by sine of, I am writing in terms of b minus a, log of secant x minus a by x minus b. Further I can write this as 1 by secant is cos plus c. Further 1 by sine can be written as cosecant b minus a, and you can write in terms of log. So secant comes denominator 1 by cos x minus a. This new denominator, if it goes numerator, become cos of x minus b. Anything fine. 1 by sine can be written as cosecant. 1 by secant can be written as cos. You can stop it here. It's correct. You can simplify. Log a minus log b is what? Log a by b. And secant can be written as 1 by cos. 1 by secant can be written as cos. That's it. Next, integration of sin square x minus cos square x by sin square x into cos square x dx equal to, what is the answer they're asking you? So split it and simplify. So I can write integration of sin square x divided by sin square x cos square x minus second term cos square x divided by sin square x cos square x dx. Now cancel the terms. So sin square cancels, cos square cancels. I am left out with 1 by cos square, which is secant square x. I am left out with 1 by sin square, which is cosecant square x. Both are integrable. The integration of secant square x is, what is integration of secant square x? Tan x. And integration of cosecant square x is minus cot x, minus of, already we have minus of minus cot x becomes plus cot x plus c. Tan x plus cot x plus c. So tan x plus cot x plus c, option A. Simple. Split this and integrate. Then e power 1 plus x by cos square e power x plus x dx equal to, what is the answer? Two methods. Integrals are also called as anti-derivatives. You take the answer and differentiate, check whether you will get the answer. And other method is simple. Internal function, take it as t. E power x into x, take it as t. So put t is equal to what? E power x into x. Differentiate. What is dt by dx? Product rule. E power x into derivative of x is 1 plus x into derivative of e power x is e power x. Product of two functions, you should use product rule. First into derivative second plus second into derivative plus first, and it will be e power x. I can take common. If I take it 1 plus x, it will be. So this is numerator if you see. So dt by dx. What is dt? dt becomes e power x into 1 plus x into dx. So now substitute in the given question. Given question becomes dt divided by cos square t. 1 by cos square can be written as secant square t dt, and the integration of secant square t is what? Tan t plus c. And what is t? T is, what is the t value? T value is e power x into x plus c. Tan of e power x plus c. So option B. And other method is what? Take this and differentiate, you will get the question. My dear students, by this I have concluded all the problems of exercise 7.3. Please sit and practice. Every problem helps you to become strengthened in trigonometry also. Inverse trigonometric identities, derivatives, chain rules, everything. If you are thorough, you can do this. So integral, if you want, if cover each and every problem of integral, indirectly you will be recollecting the derivatives and trigonometry. Thanks for attending. I'll see you in my next session. Thank you.